Hello everyone. This week we have chapter 9 to cover. This chapter is related to the hypothesis testing and more specifically on single population. So after finishing this chapter, you should be able to formulate the null and the alternative hypothesis, determine how to check whether to fail to reject or reject the null hypothesis. And of course, this would be based on a critical value that you will decide. Usually we have the 1%, the 5%, and the 10%. Most research papers, they will use the 5%. So you can think of the 5% significance level or the 95% confidence interval is the default. Okay. You will also learn about what is type 1 and type 2 errors, and also you will learn about the chi-square distribution. So in this video, I will focus on certain tests, on how to perform them using Stata. So the first command I'll show you is related to slide 25 of this chapter. So let's go to slide 25 and see what's the test. So this is a test. You're given some information, you have a sample, so n stands for the sample size of 64 observations. It has a mean of 53.1. We're assuming that we know the standard deviation of 10, okay, and it's assumed to be known because sometimes it's not known or it's unknown. And then you want to perform the z-test. The z-test is actually, you want to test the difference, right, the gap between the sample mean and the population mean, right? So the sample mean is the one given here in the story, which is 53.1, and you want to see how far it is from your guess, right? Let's say the guess is 52, or you read in the newspaper that the mean is 52. Let's say after you graduate from college, how much you're going to earn per year. Let's say you found in Google that the average of newly graduated students from, let's say, economics department is 52K. This is just an example. So this is a population mean. So you want to see how far the sample mean from the population mean, right? And then you divide it by the standard error, which is the standard deviation divided by the square root of the sample size. And you get this number, which is 0.88, right? The next step is you want to see whether this 0.88 is in the rejection or area or in the acceptance area. You have also to decide whether you're using a one-sided test or a two-sided test. So let's say if I'm using 90% significance level, then I'm left with only 10%. If I'm using 90% confidence interval, then I'm left with 10% significance level. And 10% significance level, if it is just one-sided, then the 10% is just going to be on one tail. If I have two-sided test, then it's going to be 5% on the right, 5% on the left. But this one is a one-sided test. So you have determined that your significance level is 10%. So the shaded region is 10% out of the everything, which is 100%, right? So you're left with 90%, the remaining area. And the 0.88 is somewhere here. This is your critical value, 1.28. You can find it if you go to the Z table and you search by 0.90, you will get 1.28, okay? And since this 0.88 is less than the critical value, right? You see it here, it's in the white area, which we call the acceptance region or the do not reject region. Then we're going to decide that we're not accepting this null, or we do not reject the null hypothesis, right? Or you can say we don't have a sufficient evidence that the mean bill is over 52, okay? So let's see how we can do that here. So in order to perform this test, we have all the information needed. N, the sample size, X bar, which is the mean, right? So it's called the z-test I. So you have the N, 64, the mean, 53.1, standard deviation, it's 10, right? It's given here, it's 10. and the mu, which is the population mean, it's given here 52. So you have all the information needed, 1, 2, 3, 4 pieces of information that you need in order to build this test. Okay, so all what you need to do is just you run it, right? You set it up and then you run it. And okay, so you get this table. This table is showing us the observations, right? The mean, the standard error, standard deviation, and this is the test. We're testing whether it's a one-sided test, right? So we have here, it's a one-sided test, as you can see, right? We're testing whether the sample mean, which is this one, 53, is statistically significantly greater than 52, right? So it's a right-hand side test. So when we check the results, what we have here, so we don't care actually about this part because this one is a two-sided test. So actually we're gonna look here.